Thank you, people, for actually showing up here today. So everyone actually find their notes, hopefully. All right. So class. Okay. Thank you, Blake. Thank you, Miss Becker. You got your notes? Okay. All right. So right here we are going to be finding. So yesterday when we finished this up, this right here, we noticed that this one was getting bigger and bigger and bigger. So we did finish this up. That this one. So infinity minus infinity.
Yeah.
4.5. So again, we had infinity minus infinity. So from there, that is also an indeterminate form, which is in this list. Where is it? Steps for. There is a whole bunch of them. One of them. All right, so we take that one right there, and then we find the derivative of each. So I'm going to take the derivative of each. So the derivative of 1 over x. So I'm going to rewrite the problem. And it was from positive. Yeah, okay. So I'm going to take the derivative of each. So the first one right here is going to be negative x to the, very good, minus. What's the derivative of sine? 1 over sine? I could do this two different ways. So let's try and do this as a quotient rule so you guys could actually see. So if I do it as a quotient rule, that might actually make this a little bit easier for you. So I would say f is 1, g is sine. So f prime is 0, g prime is cosine. And so if it's a quotient rule, f prime g minus g prime times f all over g squared. So the 0 times the sine makes that sine go away, right? So it's 0 minus cosine x over sine squared x. So I could rewrite it as negative cosine x over sine squared x. So this technically is an answer. It is one of the answers, but I could also rewrite it. So normally when you look at your flashcards and it asks for what is the derivative of 1 over x, what else could I call 1 over x? It's cosecant, right? Or I'm sorry, not 1 over x, 1 over sine, I apologize, sorry. 1 over sine is cosecant, right? So I could take this and I could rewrite it. So that's what I'm going to do. I'm going to rewrite this so I can actually have a different answer. So this one's going to be a, let me see, what's that going to give me? Minus cosine x over sine x times 1 over sine x. Cosine over sine. What is cosine over sine? Is that cotangent? Did you get the notes? Okay. That's cotangent. So it's a negative cotangent times 1 over sine is?
Where did you get the 1 over sine from?
Isn't that sine squared? Isn't that just sine times sine? Yes? Okay. So this, both of these are correct. So for either of those, and because I already have a minus sign out front, because I didn't take the minus sign into my derivative here, I have the minus sign out front, and I have a negative cotangent cosecant, so it becomes a positive cotangent cosecant x. I'm going to rewrite it 1 over x squared
Wait, wouldn't the 1 over sine be cosecant?
1 over sine.
Yeah.
One over sine is cosecant. Yeah. Okay. Now there's a reason why I left this up here. This is going to make my life easier, especially when I'm trying to plug that in. So it's going to be negative 1 over x squared plus cotangent, which is the same as saying cosine over sine times 1 over sine x. Huh? I know I heard something besides sneezing. All right, so now as I plug it in, as I start plugging in numbers, again, 0 from the right-hand side, so those are going to be my positive numbers, but it's going to be really, 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 really small numbers. Really, really, really small numbers. So let's pretend like I remember what I plugged in yesterday, which is like the 1 over, let's go 1 over 8. Is that a small number? Yes. Is it a positive number on the right-hand side of 0? Yes, it is. So again, I'm going to take that one. So it's going to be 1 over 8 squared is going to be 1 over 64. And this turns into negative 64. If I said f prime of 1 over 8. So if I'm trying to plug it in like that. But I still have to do my limit for this. So what's going to happen as this gets smaller and smaller and smaller? It's going to keep getting smaller, but what happens when I plug it in though? Just this piece right here. It's going to go big. And it's going to be a very big, what type of number? Negative. Okay, let's go to this next one. 0. As cosine approaches 0 from the right-hand side, that's getting closer and closer to 1. Getting closer and closer to 1. What about sine at 0? Sine at 0. I can't have sine at 0, right? Again, I get smaller and smaller and smaller and smaller values on the bottom. So as I get smaller and smaller values on the bottom, kind of like we had right here, I'm dividing by more and more numbers, right? I keep dividing by more and more and more and more. So because of that, this is going to give me a very large number. So if I again say sine at 1 over 8, and I'm going to show you guys, so this is kind of what I was trying to go over yesterday, but the bell rang, so I wanted to show you guys all this. Especially with sine and cosine, so you got to actually... Okay, now I'm going to plug this in. So to show you, it's in radians, so 1 divided by sine of 1 over 8. Since it's 1 divided by that number, what's happening every time as I'm doing that? As I'm getting closer and closer, number keeps getting bigger, right? And that's what I was trying to show yesterday when we had this right here. As I got right here, it kept getting bigger and bigger and bigger, and that's the reason why it had infinity. And so right there it's going to be, and that's going to be the same thing that's going to happen over here. So that's going to be there's a plus sign. Now 1 over x control divide 1 over x minus control divide 1 over sine x. So what am I trying to prove here? What am I approaching? I'm approaching 0, the limit, right? So the limit, as the limit approaches 0 from which side? From the right-hand side. So I could actually hit a trace, menu, trace, graph, can I plug in 0? I can't plug in 0, right? Because it's going to be undefined right there. But as it is tracing it, going this way, it's getting closer and closer to what number? 0. So in this one right here, I have infinity, infinity, and I have negative infinity plus infinity squared. So either way, I'm still infinity, infinity. I'm still going to end up at whatever I have over here, subtracting infinity. So in this case right here, it's all going to cancel out. So my infinity, infinity, whatever I have there, it just ends up becoming 0. So as I'm approaching it to the from the right-hand side, it's going to give me 0. So I think I probably should have started with the graph here to show you guys that we can do it, but as we approach this, it is just going to give me 0.
So how do you know when it's gonna give you like natural value, and how do you know when it's just
Let me open up the front page. Right. It's one of these. I have infinity minus infinity.
Yeah.
Okay. If it comes up to that, those are one of the types of it. And today we're going to do these ones here. Or infinity times 0.
But how did you know it was 0?
Infinity minus infinity is an indeterminate form. And I could have did this multiple more times. I think this one actually requires like the third. Let me see what it says. So I think this one is the third. Yeah. So we'd have to go through and actually redo this whole thing. This one right here, it gives me indeterminate here. This one right here doesn't work out like this. Why is it not going to keep working out like this? What's going to happen every time I take a derivative of this first piece here?
It's just gonna change from the x versus x.
To higher, right? And it's going to alternate, right? Okay, positive and negative, but it's going to alternate, but every time I'm still going to get infinity, right? And every time on one of these, since it's going to be times this, it's also going to be what? It's also going to be times an infinity here.
So this one you can't find, you couldn't find any of it.
I cannot find any of those, and I'm going to show you the other way of actually doing this one, especially when we get into the problems. That you see that it does work out in the graph. You see that every single time I do this, it's going to come up again, right? It's going to give me the same thing again. I'm going to rewrite this. So, can we make this into a common denominator? Yes. Multiply the left side of this by sine x over sine x. What about the right side over here? Multiply this side here by, what's missing from the denominator? X. X over x. So now, if I'm looking at it, I'm going to get sine x minus x over x times sine x. I'm rewriting it. Can I plug in 0 there? Let's plug in 0, what we get. So 0 minus 0 is 0. 0 times 0 is 0. This is going to make life easier because this was a infinity minus infinity, right? And every single time when I kept doing it as is, I kept getting infinities. This right here, I got 0 over 0. Now what I'm going to do is, I'm going to say, this top piece is my f, This bottom piece is my g. F prime. Derivative of sine is going to be cosine x minus derivative x is 1. G prime. That's a product rule, isn't it? Yes. So product rule that. So that's going to be 1. So it's going to be sine x plus x times cosine x. Now we're trying to plug in the 0. Cosine at 0 is 1. 1 minus 1 gives me 0. Sine at 0 is 0 plus 0 times cosine, which is just going to be 0. So what happens if I get 0 over 0 again? We had a problem like this yesterday. What happens if I get 0 over 0 again? Do it again, right? Okay, let's do it again. So f double prime. Derivative of cosine is? Negative sine. All right, g prime. So I have a regular derivative. Sine is negative cosine. No, positive cosine, sorry. And right here, it's going to be plus. That's a product rule, which is going to be cosine x plus x negative sine x. I'm sorry, this is double prime. And now I'm taking the limit as x approaches 0 from the right. Derivative sine at 0. So right there, sine at 0 is 0. Now, for not to get the indeterminate again, I need to get anything but 0 here. Anything but 0, but not infinity. All right, so cosine at 0 is 1. So 1 plus cosine at 0, 1. So negative sine times 0 is 0, right? There we go. Because this piece right here gives me 1, this piece gives me 1, and this right here gives me 0. So I get 0 over 2, which is an answer of 0. So these are one of the more complicated problems, especially when you're dealing with infinity. And I plugged in the calculator, be like, dude, this does have an answer. I know the limit from the right-hand side because of the graph. It is approaching 0, but I need to show it mathematically how it's going to approach 0. So what did we have to do? If I have infinity minus infinity, what did I do because of that? Rewrite the problem so I could work with a 0 over 0. If I could do it again, so rewriting it, and now I got 0 over 0, that right there is my step from this. So yes, these problems are actually going to be a lot longer, but when you only have 2 questions for your home, I think it's 3 on this one, 3 questions on this set. So, make sense or no? I know this one was long. Okay, here's the other one. Steps are finding indeterminate for these ones right here. When limit as x approaches c, f of x raised to the g of x, when f of x raised to g of x is an indeterminate form at c in the type of 1 to infinity. Think about that. What's 1 squared? What's 1 to the third power? What's 1 to the 10th power? No matter what, as I keep getting larger and larger and larger, 1 to infinity is still going to be 1. So that's important. So that's a type. 0 to the 0. Okay? Most people think anything to 0 is 1, isn't it? But let's see. 0 raised to the 0. It is undefined. So that is an important rule that you have to know. 0 to the 0 is what type of number? It's undefined, as long as I'm not texting right now. So, undefined. So if I tell you guys, like, hey, what is 0 to 0? You would tell me it is? It's undefined. Or infinity to the 0. That's another one. Because we know anything to the 0 power should be 1. But infinity is it a number? Say no. It's an idea. If I can't put it on a number line, it is not a number. All right, so let y equals f of x to the g of x, and take the natural log, ln both sides, obtaining y ln y is equal to g of x times ln f of x. That's important. So this step rewrites. You rewrite it, the problem. So find the limit as x approaches c of ln y of this. So I get this. And right here I get ln y is equal to the limit. Then limit of this is equal to e to the limit. What did it say to do? Did it say rewrite it, right? Okay, so what is this going to give me? This is going to give me 0 to the 0, which is indeterminate. Okay, said rewrite it. ln y, okay, is equal to g of x ln f of x. So it's going to look like this. Okay, g of x, which is the outside, is going to be x times ln f of x.
How did you get G of X?
Right here. I don't know. Can you see that right there on the paper? I know it's kind of blurry and small. It's your exponent.
Oh, okay. All right.
I'll give you a second to write that down, especially since it is blurry. You guys got it, Wade?
Yeah.
Okay. All right. So that means that I'm going to have limit as x approaches 0 from the right. that a product rule?
Yeah.
Okay. It's a product rule, so go ahead and take the product rule. So 1 ln x and that's going to be plus ln x. What's the derivative of ln x? I almost heard you.
Oh, 1 over x.
Yeah, 1 over x. So it's x times 1 over x. So, right here, plugging it in. Anything times 0.
0. It's 0.
Okay, so right here I get 1. And this one here.
Wouldn't that just be undefined?
It's approaching it.
It's approaching infinity.
I know. Did I did my math wrong? I need to double check now.
How did you rewrite the?
How do I rewrite the?
The extra x as the x is other equals. Oh,
This?
Yeah, I got it. I got it.
Oh, from here. Oh, okay, so, yes, I did make a mistake and I made it right here. So, the limit for this one, because I didn't check this one. So, if I plugged it in, this right here, if I plug this one, this gives me 0. By rewriting it, that gives me 0.
Because ln x is undefined.
Anything times 0 is 0. But it's from the right hand side. It's not at 0. So right here, technically, it's going to get closer and closer, so it's a small number. But this one right here is going to give me 0. 0 times that small number is going to give me 0.
What is L?
What is what?
Like, because it says step 3. What is L? Step 3.
Oh, capital L?
Yeah.
That's a limit.
Oh, okay. So just 0.
Yeah, capital, yeah. So that's where you get from that.
So it does equal 0.
And so I have, so going back to this, so it's going to say the limit as x approaches 0 of what I had, which is my ln y equals 0. So I took this right here. So I did this piece right here, and I still have this piece right here. And set it equal to my limit. My limit here was 0. And then how do I undo an ln?
Even
E both sides, right?
Yeah.
Okay, so now as I e this on both sides, it's now going to read e to 0 is equal to y, where I could take the limit as x approaches 0 from the right.
Where did you get all this?
Are you okay with this piece right here?
Yeah.
Okay. When I ln both sides, let me start over again. So it said limit as x approaches 0 from the right of the problem. What was my problem? My problem was x to the x. So if it is a 0 to 0, 0 to 0 indeterminate, then I'm going to ln both of these. So now this was y equals x to the x. I'm going to ln both sides. And when I do that, if I'm taking ln, what happens to the exponent? It goes out front, right? So it's x times ln of x, right? Now, can I take the limit as x approaches 0 from the right? Now we're doing the x, right? Not the y. And that gave me 0 for all this, right? So all that, as I plug in my x's, that gives me 0.
Which means that ln of y equals 0?
ln of y. So now the whole thing right here says it's going to be limit as x approaches 0 from the right of ln of y is now equal to 0. Now, because I don't have y, I have ln y. I have ln y now, not y. So I'm going to e both sides. So I'm going to e both sides. So when I e this side, I now get rid of my ln. So now I have the limit as x approaches 0 from the right of my function y equals e to the 0. And e to the 0 power is 1. So my limit as x approaches 0 from the right is equal to 1. Or, like Blade was saying, capital L stands for the limit. Tab, right here, hit tab, and it's going to be x raised to the x. Showing it graphically. So as it's approaching 0, anyone know what that thing is called? What's that called there when the graph looks like this? Huh? A malfunction. There's a special word for it. Oscillating? It's oscillating, so it's up and down real quick. As I keep zooming in closer and closer and closer, it's going to keep going, oscillating up and down. So from here, from the graph by itself, we can't really pick it out. But what we did is L'Hopital's rule with the indeterminate is going to give me that the limit as x approaches 0 from the right-hand side is going to be 1. So it's going to cross here at 1. Right? There we go. That point right there is 1. So where it crosses the y-axis right here when x is 0 is going to give me 1. Menu, trace, it's undefined there, but as it's approaching 1. All right, so, all right, I guess that's it. I'm gonna leave off. If you actually want to look at this one here, it is example 10 in the book. Okay. So make sure you guys like, share, and subscribe. Hit that notification button.